Hi, my name is Sven.freudenfeld. I'm representing Kontron here at the Intel booth, and we are a premier partner of Intel and providing platforms for media processing in the market. We've been focusing on the next generation technology from Intel, leveraging on the Iris Pro technology. We have now our third generation platform where we're using the Intel E3 1200 series version 4. And we are leveraging the GPU to do media processing, in particular to support HEVC and 4K. So we package 18 CPUs into a 2U form factor as a base platform, and we evaluate, or we evolve the platform by introducing new next generation Intel processors into the platform to be better optimized in video processing. The same platform can be scaled for network PVR applications and so on because of the modularity of a platform. So what we have here is a use case of 4K transcoding where we can reach a broadcasting quality level for 4K at 60 frames per second. It's a significant increase in performance. So we have seen a 30% increase from a previous generation, the i7, in terms of GPU performance. And with that in mind, we can actually now today already focus on the software HEVC implementation and 4K implementation on the same platform. So this is pretty much the enhancement of our platform from the previous generation. And at the same time, we already been working on the upcoming generation as well. So we see more stable video processing, much better quality in a high-dense platform to go to the market. We have a couple of customers from a ISV perspective, so there's a lot of players like StarTimes in this case where we use their implementation for HEVC and 4K. There are other ISVs which are publicly known today. We have done proof of concepts in the past and as well production units with a company called Sven.freudenfeld. The other use case will be with a company called Active Video Networks, which has been acquired by Iris. So they're using the same architecture for the Cloud TV implementation. And of course on the service provider and the broadcasting side, all the cable operators are interested in having a low footprint or a high dense platform with low power consumption to be able to scale up and scale down on the network demand for video processing. We started this project initially with the Iris Pro technology about 3 years ago with the first generation, leveraging the GPU or the graphic engine, the Iris Pro, to do media processing. It was an initial step to actually bring some of the functionality from a FPGA or DSP type of architecture into a standard-based x86 architecture with a GPU implementation to do media processing. And it turns out that using that functionality on that technology we can actually virtualize some of the functionality much easier than traditional FPGA and DSPs because we are able to manage that resources dynamically in an environment which could most likely be deployed in the cloud environment. So we're virtualizing the GPU resources, so we need to be able to dynamically allocate resources. On an x86 architecture, it's very simple. We can use an OpenStack framework, but on the GPU it's a little bit more complex. And the virtualization aspect is to be able dynamically to allocate resources on the fly without any reconfiguration or any repurposing on other components in the network. So the platform has a framework to be deployed in some of the networks, not only for broadcasting, but also for telecom. So network function virtualization. So video is one of the key aspects for network function virtualization, as well for the 5G deployment in 2020.